Wow, incredible that the room is so full. Hi, my name is Hannes. Thank you very much for introducing me. I just flew in from Berlin yesterday, and I'm very happy to be here and stand in front of such an amazing crowd at this wonderful campus. So indeed, I'm the founder of the Interoperability Hub, so I'm involved in science entrepreneurship for a couple of years now. I coordinate entrepreneurship education at my university for the last 7 years, and currently build up a science entrepreneurship program for all 3 Berlin universities. So this is really what drives me right now, thinking about ways how to make more postdocs go into entrepreneurship. I'm not sure whether this is my job, but maybe that's part of it. Thank you very much for introducing me in such a way. So indeed, I am involved for the last 1.5 years on the question on how startups use biodata. So we have traveled across Europe, particularly interviewing founders of startups to figure out what is behind their use of biodata. And I would like to share a couple of our insights with you and be particularly open to the discussion that we might have afterwards on a couple of issues that I may raise and also maybe the conflicts that I might bring up here. Good. So the question overall is leveraging infrastructure. So we started with ELIXIR, looking at, okay, how do these startups use the biodata infrastructures that you provide here, for instance, on this campus? So, and I would like to start by the question of, since I know that this is a rather diverse group and not all of you are entrepreneurs, by the question of what is it that entrepreneurs actually do? So what is their job? What are entrepreneurs really doing? And actually, when you go to an entrepreneurship class, and I just went, so the last 3 days I was on several entrepreneurship classes, lucky me, what you regularly hear is this kind of talk. So most startups fail because building a product for months or sometimes years leads to failure because most startups don't understand their customer groups. So what we do in research basically is we build platforms, for instance, for a while. So I created a platform for over 2 years just to find out that the customer segment that we were looking for was a really bad customer segment. And we tried the next one and that failed as well. And then I ended up in academia again for some reason. So this happens all the time. So I see a lot of scientists starting out companies with a very, very limited understanding of customer groups. And this is what you see regularly also in the market. So this is a very nice example of one of these famous Silicon Valley startups that just created a product that nobody really wanted to have. It's like a juice maker that costs $700, I guess, and gives you the packages that you bring into. It's all proprietary. And so each juice costs more than tens of dollars. So no one really wanted to have that. However, they found some investors for whatever reason. In the end, the startup failed because they just creating a solution that no one really wanted. So long story short, what entrepreneurs regularly doing is, or what they have to do is they have to figure out what problems do exist, what kind of solution can I provide. And this is also what digital entrepreneurs do. So as Kathy already mentioned, I founded this digital entrepreneurship hub. So digital entrepreneurship is a particular sub-theme in this kind of entrepreneurship research. So we are looking into entrepreneurs who use digital artifacts or platforms or infrastructures to provide solutions to existing problems. So the good thing is that there are a lot of different platforms and services out there that we can rightly use, integrate into each other, and then create an interesting new product to an existing problem. And what we do essentially is we just link the existing solutions that we know of and link them to problems that we find in the market. It sounds pretty straightforward, and this is actually building on a lot of research that is already going on since the 60s, 70s, for instance by Herbert A. Simon, who was very much looking into this problem-solution matching. And entrepreneurs do that because that's their main job. So they have to find real-world problems that are so dear that someone is willing to pay something to get this problem fixed, and then creating a solution for that problem. In the end, you see all of the different problems that are potentially out there, which we refer to as maybe a problem landscape or a problem space. And the entrepreneurs have to pick some of the problems that they want to solve and then find the best solution or one solution that is able to fix that. The gap between both is that on the one hand you have these problems that might if I solve them, might give a benefit. On the other hand, you might have a solution that comes with certain costs. For instance, if I would want to use some scientific insights to solve a problem out there, it might come with a lot of costs, right? So if I want to solve some kind of cancer out there, so come up with a drug, it might involve billions of dollars to actually bring this drug to the market, as you all know, I guess. So taking this, digital entrepreneurs, however, are in a little bit different situation than many of the entrepreneurs within the last the decades that have come before. So digital entrepreneurs leverage the technologies that are out there in new ways. What does that essentially mean is that the solution space that is out there, so the many solutions that are out there, are in some way or another enable us to reduce the costs of bringing them into the market. Let me put that into perspective. If you would want to start an artificial intelligence startup 15 years ago, you would have needed a couple of computer scientists, in particular, maybe a mathematician, right, to find a solution to create a neural network, for instance, or some kind of other machine learning technique, and bring that into the market and solve some kind of a real-world problem, maybe reducing fraud. Today, I'm currently mentoring a team consisting of only business administration people, starting a company in this kind of field, using neural networks, using existing technologies, is particularly Google TensorFlow, which just reduces the costs for them to bring to develop a product that is rightly marketable. And this venture has now just raised another round of money, so they were able to bring a product into a market to an existing face an existing problem just because Google provided them the technology to do that. And I think this is one of the main leverages of digital technologies today. We can use them and easily prototype new solutions. And digital entrepreneurship, however, doesn't stop there. So it's not about only creating a one-time solution. So therefore, I'm a little bit struggling with all the entrepreneurship classes that I regularly participate in. It's not about creating solving one problem once. It's creating a solution that solves problems at scale. And therefore, we learned that digital technologies, again, are very good at this, right? So we can use a lot of different mechanisms that come with digital technologies to create scalable solutions. And then there is hopefully an investor who also believes in this kind of scalability and throws maybe tons of dollars on us so that we become this kind of a thing, what we now refer to as unicorns. So digital technologies in that sense are pretty nice because they separate the medium from the content, as we know, right? So nowadays we don't need any printed out posters any longer or CDs. We just go into the cloud, and digitalization has reduced the marginal costs of our information, for instance. It also enabled us to build flexible products in a very flexible way. For instance, as we have so many libraries available, we are now in a situation where you can actually take a group of 3 people, put them into a hackathon within a weekend, and they can come up with a solution. And if I give them 2 days more, they can come up with a comparable solution, but maybe on another medium. So maybe it was first a web-based software, and then they just take similar libraries, put them together in a different way, and then maybe it goes to Apple iWatch. So digital technologies give us a lot of opportunities to build products on scale. So this is my basic line of research, so this is what I'm really interested in. And as I said, in the last years, I'm very much interested in how do scientists actually create solutions and become entrepreneurs. So the basic research question that we stated for ourselves is, how do these digital entrepreneurs match problem and solution from science data, right? So not only from like in these like e-commerce spheres that you might think of when you think of digital entrepreneurs, but how do they use science data in a way that is actually scalable? So that was the premise with which we started. So we started looking at science data. So I can't tell you anything new here. I think you're much more familiar with these kinds of things than I am. So one of these papers that I'm referring to is actually originated here. So you know that genomics data is like growing exponentially. This paper that I'm citing from is actually saying that most of the genomic data that is going to be available in the next future is not coming from the public, but more from the private sector. So, but anyways, right now we have already a lot of genomic data available for us. So, and much of this data is actually globally expanded, so globally disseminated on different research infrastructures. Most of them right now still on public infrastructures. Particularly in both Cambridgeshire, so here and the Boston area, so which has definitely some historical reasons, but also you are more familiar with that than I am, I guess. This is great because this data is available not only for scientists but potentially also for entrepreneurs. So there could be startups, or there are startups out there that might use these data sets. Data for us is, however, nothing that we just say is facts. So we acknowledge that as you as scientists, you create data, you create it with a particular intention. And this intention, and therefore I think it's important, maybe not to start a company. So when you create data, or you manage data, or organize data, so I guess you are all scientists, or most of you are, you create this data with a particular problem in mind, which is regularly testing a hypothesis or creating an hypothesis. However, if that is the case, data has to be interpreted depending on who's created it, with what kind of skills, what's the background knowledge associated with this kind of data sets, what are the circumstances under which it was researched, and therefore, unavoidably, data is value laden. So you cannot take data out of its original context just as easily as one typically might think when thinking about data. So data is more than just zeros and ones. And this is important because as I learn regularly when I do these postdoc workshops, what scientists regularly do, so the kind of goals that you have and the kind of practices that you perform, fall significantly apart with what entrepreneurs do. So many of the things that, for instance, scientists do is regularly, not all of them, of course, but creating data sets for example, for one-time purposes. So like creating a data set to solve a particular problem, a scientific problem. So testing a hypothesis once. And then once it's tested, creating a publication out of it, hopefully get this publication published. I'm paraphrasing here. Hopefully get this publication published, and then being happy about this, and maybe a follow-up publication can come on later. However, this is not what entrepreneurs actually are looking for. Entrepreneurs have to build anything that they create has to work repeatedly, because they want to sell a product regularly in an environment that has very high quality standards. Therefore, science data, from their perspective, might be a common pool resource. However, it's messy, and sparse, and incomplete, oftentimes unstructured, and non-standardized. And this is a problem for people who are working in an environment that has this high quality standards, for instance, as the pharmaceutical companies do. So, and the other thing is, and this is something that I learned also while spending time with scientists from the biological sciences, it seems that scientific advance leads to changes of metadata all the time, because you advance research. So, which means that the way how data and science is structured changes all the time. And this kind of a change of the data structures leads to problems when you want to apply a product that has to be as stable as possible, right? So somehow these startups have to manage the kind of fluidity that you create as you create new research advances. So laying this ground, I would like to share with you a little bit of an insight of what these startups are actually doing. So right now in Europe, I've looked about across Europe and looked about what are the startups that we currently have in Europe. Most of these startups are actually in the United Kingdom. Many of them originate or somehow linked to this place, which makes completely sense. when it comes to biodata companies. A biodata company for me is a company that relies on a business model where data from the biological field, may it also be life science, is a key resource. So it's heavily data is in the core of their business. And this can mean many different things. This can mean either it is an app that provides some kind of healthy living, such as Fitness Genes, where I'm not saying that it's good products, I'm just saying what's out there, right? So this goes to all of them. Fitness Genes, where you upload your data, and then they give you like advice on how you should go on your fitness regimen, or these health reports that I'm sure that you are aware of from 23andMe, where they have different business models on using genomic information there. There are also diagnostics tools that are deeply settled within the life science industries that are actually used in practice and by practitioners in the medical field, and go nowadays even beyond from ancestry, where you have these ancestry reports, to DNA Romance, which is a very crude startup that tries to match people based on their genome, with many also ethical concerns, I would say. So as you see, there are a lot of different applications that you can see out there. And as I want to show you, most of them, if not all of them, rely on some form or another on the research that has been going on in the genomics field. So we did a survey on these startup founders, like only got it filled out by C-level founders of these startups, so far 43 from them, and asked them a couple of questions, among them, to what extent do you rely on these different infrastructures that are provided in the on open research data. And what we found is, first of all of them said to some way or another, without any kind of research data that is available, we would not exist. And interestingly, many of them applied several resources, being the one on the upper layers, those the one that were mentioned by most of them. So one of the core findings for us was really it is for the startups most of the time very important to have these research infrastructures such as Campbell or PubChem or and all of the other infrastructures, having them available, because if they wouldn't have them, they would not be able to start a company in the first place. Right, so we didn't stop there. So that was, for us, kind of the first step to really understanding whether they use this kind of science data. And then we wanted to figure out, okay, what are you actually doing with science data? I'm not going too deeply into that, but what we wanted to do is we wanted to do a more qualitative study. So meaning that we interviewed them, that we went into the field, trying to understand what these the startups are actually doing, and created a study of 15 startups that we think are fairly representative of those startups that we see across Europe, and figured out what they are actually doing with data, with the science data. And we came out with 3 different mechanisms and wanted to relate them to how they actually then scale their business. And I would like to share a couple of stories about them, if I may. So one thing that I see to somehow form or another, maybe all of the startups have done to some extent or another. So is what we refer to as contextualization. This contextualization is a process that takes science data and links the semantics very closely to a goal that is driven by a business problem. So what these companies do is actually, so the first thing is they customize the kind of goals, so they figure out, okay, what goals are out there that can we solve, and then customize the semantics to fit these goals. Let me illustrate that on an example. So this is how this might look like over time. So at first they start with, okay, so I have a science, I had a science research project. So there's one company that was working on one of these infrastructures across within Europe, and they figured out, well, maybe this is also interesting for a company in the pharmaceutical industry. So what they did is they started a project which is kind of this link. So it's a singular problem solution to one single customer, which is a huge pharmaceutical company. And they started with this interacting on a project base with this with this pharmaceutical company, and then they provided the software, started building the software for this particular company. So they figured out this is something that is of interest to them once, but not really scalable. So what they began then is they started another project. They started different, so a different problem, something that they still were able to do because they knew how to solve it, and started to address a different customer in the same industry but with a different problem. And again, project, doing another project, and then going again and doing another project. This is a kind of a mechanism, going project over project over project over project, that is fairly familiar to many scientists. And I think this is one reason why many science entrepreneurs or many scientists who start these kind of startups are pursuing this, because it is fairly applicable to what they know already. It's like finding grants, going into a project, doing the next project, keeping my project team running. So seeing my startup is actually only my research group in a different way. And at some point or another, they hopefully realize that, well, only going for project is not really scalable, it's not really something that is sustaining me, so maybe I have to create a product again. And this particular company, for instance, and they found a pharmaceutical company, another large pharmaceutical company, to create a repeated problem solving. So they created a software. This software was heavily contextualized to this one customer. So it was certified by this one customer, it was audited by this one customer. They created an ontology that is fairly only be usable by this one customer. However, this customer, luckily, is giving them enough money to keep on going. So this is the kind of contextualization. I see that in I think to some extent in all of the startups that we've seen, but most of the startups actually have gone further than that. So because contextualization is very context specific, it has one problem, one solution. Another mechanism that some of them have used on top of that is what we refer to as decontextualization, which is a process that detaches the data from its goals by predefining semantics. So they find some kind of maybe an ontology. Someone referred to it as an Uber ontology. So they found this Uber ontology that links different ontologies that you created in science maybe, and linked them together. And for this, they kind of form this one of Uber ontology, and then they test out where does this Uber ontology apply. And this is how this might look like. So they started creating this Uber ontology, and this is this solid line means that it's a repeated problem with multiple customers. So there are a couple of startups out there that create these kind of Uber ontologies that link between Campbell and PubMed and all these different infrastructures, and create link between them to actually help pharmaceutical companies for the first time search these different infrastructures on an easily applicable way, so an easy way with an easy user experience. And then they mostly give it out for free, so it's mostly free that you can search these different infrastructures. And then they provide additional projects based on what these different companies find. So if a pharmaceutical company uses their search and then comes to an interesting potential insights and wants to link their proprietary data now to this open data, they go to the startup and tell them, why don't we build up a project? And then they start building up a project. So the good thing for the startup in that sense is that they then link the proprietary data to this Uber ontology that they created in the first place, gradually expanding their ontology. And then they gradually expand their ontology, which makes it easier for them the next time to link the next company, and then link the next company. And so gradually they expand their ability to attract new customers. in a very easy and more cost-efficient way. And this is really, so this is what we call decontextualization. And this Uber ontology is just one example of this, but it's a very prominent one. And then the final mechanism that we found is what we then refer to as more recontextualization. So once you have this predefined semantics, so if you've done this a couple of times, potentially you find you go into this recontextualization as a process that links data with goals by aligning these predefined semantics. Let me illustrate that on a different example. So what you do at some point, you will be able to address a problem, find a problem that is fairly scalable. So maybe I found a particular biomarker to address a particular kind of disease, or to maybe predict the relationship between. So that's rather odd, but so predict the relationship between different people maybe, and then I can build up a data pipeline to process this kind of data and become very, very efficient in the process. What these companies rely on is that these kind of semantics keep being very, very stable, which means that when science get involved, when they get in touch with research infrastructures, science infrastructures, what they very regularly say is that, well, these data sets are very, very messy. I cannot really work with them, because what they want is they want a very solid and stable relationship. They say, okay, what we're doing here is very high quality service. We cannot rely on this messy data. So every time they work with science groups, or with research groups or research infrastructures, they double check. They do a double quality check to control the kind of impact that this misalignment might provide. So they design a very specific solution in the end. So maybe based on one particular biomarker, but since they build up this very nice infrastructure, and since they know how to build, how to stabilize the particular semantic, they are at some point or another able to address a similar problem, which is not that far away from the first one, but address the similar problem, and then slowly, gradually scale as they address more and more problems. So what we essentially then found is that this is actually the way that we see most of these companies kind of scale. When we talk about scaling, mostly we think of Facebook or these kind of companies, right? So scaling is something, you get a lot of users. This is not true for these kind of startups. These startups cannot find millions of users because there are not millions of pharmaceutical companies, obviously. However, I can sell a product a couple of times to a pharmaceutical company if I solve a couple of problems for this pharmaceutical company. So all of them, they are B2B companies, so most of them are B2B companies. Even the B2C companies like 23andMe, they actually make their money with B2B. So if you want to address B2B companies in that sense, then you need to find the different problems that you can to offer new solutions to them. So either you therefore find these new problems, or you offer multiple solutions for the same problem. And this is the way that we found that most of these startups actually scaled. So to cut this a little short, all of them, or most of them, start with this kind of contextualization. Start just doing what you do in research. There's a new problem. Okay, this new problem is a new hypothesis. I have to test it. Then, okay, so I'm building up a research project in my startup. Solve that problem. Fine. Next problem. Fine. Next problem. Fine. At some point or another, they hopefully find that there are problems, that there are similarities between the problems. So for instance, there's one startup that has gone over 120 projects within the last 6 years. 120 projects. I think they are 10 people. And at some point 2 years ago, they recognized, well, one of the problems that we regularly face is how do we annotate this data? So they created a solution to build annotations. And this is, first of all, they did it only for themselves. So they created annotation software to help them be more efficient in their projects. And now they launch a project for annotating. They launch a product for annotating. So they really thought about, okay, how can we move back from this contextualization? Because contextualization is really bad if you want to build a scalable product, scalable company, because you can only scale by people. How many projects can you actually manage? I'm not sure how efficient you are, but I mean, managing project means manpower. And scaling manpower is really, really complicated, particularly if you need bioinformaticians. I mean, where should you find all of these bioinformaticians to hire? It's really, really complicated. So at some point or another, you want to find different models. So therefore, we found most of the startups that actually scaled. So actually were able to go into Series A, Series B, to build up more employees, like up to 200 employees, to go first to decontextualization and then to recontextualization or to recontextualization right away. So that they were actually able to like stabilize the semantics that in science all of the time changes, but they they are able to stabilize for their company, for their business customers, in order to solve their problems. So. My final slide before we go into, before I would like to open this up to discussion as well is, so we hope that, so what we're currently heading on is, we hope to introduce these mechanisms to showcase how you can actually use use science data and build up companies from it, companies that potentially scale, because I think this is something that we oftentimes undermine as we think about entrepreneurship. How do we actually build companies that scale beyond a couple of problems and not only solving one. And I hope that we also provide a couple of insights for our own research as we now find a different angle on going on these problem solution strategies in the way. I think also that we provide a couple of implications, potentially also for research infrastructure, because something that I recognize and maybe cut through a little bit is what many of these startups are building on is that there is a gap between science and industry. And the FAIR movement is actually opposing this. So while so I'm not sure whether you understand what I mean. So if I build a search engine that makes all of these infrastructures available, then I am making searching infrastructures easy for industry. And this is what my business model then builds upon. However, if you come now and build everything fair, everything's great, everything's easily scalable, everything's easily searchable, I a little bit drag their business model away, because this is what they're currently building on. I'm not saying that it's a bad idea. I'm just saying there is a conflict, there is a potential conflict. And I'm pretty sure that in the end of the day, as we see, as all of them they build on research infrastructures, fair infrastructures will in the end lead to more interesting, innovative ideas. But right now there are a couple of companies out there who would be might face problems from it. Okay, so with this, maybe there's a bit of a contrast or conflict here. I would like to open up the discussion because we have, I think, what, 20-25 minutes or so. And I would be very, very interested to hear your experiences also with the companies. I know that there are a lot of companies here on campus and close by that you've faced. Thank you very much for your attention and for bearing with me. Sure.
So, no to the question. So I was struck about the last statement, Hannes. I think that so that linked to something. So the question I wanted to ask, but I think it links to what you just said. So when you looked at these companies, how much of the business value were in the sort of technology space, i.e., essentially in the semantic axis, proprietary semantics, or the linking technology, and how much of it is in the business model or in the business practice, i.e., how do you go about solving the problem for the customer? because the latter is in a way harder to copy. And I think that relates to your question on fair in the sense that, well, if you make data more fair, whatever that means, but more accessible for more people, if your value add or innovation is around that sort of semantic axis, then you're in trouble. If your value add is on a sort of business model, business process practice, then you have less to fear from that.
Yeah, so
I wonder if you could give a sense from the companies you talk to where they sit in that space.
Right. So I'm a little bit questioning whether you can really separate both.
Okay.
Because right now we are assuming that we can that we separate the goal. So the goal of a pharmaceutical company is looking for a particular diagnostic.
Mm-hmm.
Whether we can separate that from the semantic structure in the data set.
Mm-hmm.
And what I'm seeing is that many of them, they engage heavily with these customers to build up, to really understand what their problem is, and then heavily customizing products to this. And this also extends to how do you organize the data. So for instance, they take these Uber ontologies, and then they go behind the walled garden of a pharmaceutical company, and then they apply it there, which means heavy linking to it. So therefore, it might be very interesting to see whether the kind of assumption that they make is that you can actually separate both. I think there is a tendency towards trying to separate it because they need to standardize it.
Mm-hmm.
However, so far I've seen that they engage in a lot of practices to actually narrowing it down to the customers.
So, from what I understand, most of those companies are very knowledge intensive. So, would you say that the majority of the startups in the kind of data-driven life sciences is created by people like directly coming out of universities, from like group leaders in universities, from PhD students?
Well, most of the people that I've talked to actually they come from universities. So therefore, I think this also explains why the map is heavily biased towards certain countries. So for instance, why are many people forming companies in the United Kingdom? Well, because many of the research groups are here. So people are trained on genomic data sets in particular institutions. So therefore, when they go out there to start a company, they don't go that far away regularly. And also, it's very good for them to be very close to some of these research infrastructures. So, for instance, as I said, there was one group that was started originally from research infrastructure, and then they didn't move so far away because they wanted to be still involved of what is changing there, what are they working on. So, therefore, this kind of interaction helped them. I've not. So one of the founders at least is always a scientist from a research group. So then regularly they take other people inside, and then it really depends on which kind of industry they are. So for instance, when they come from pharmaceutical industry, if they address the pharmaceutical industry, so one of the founders, for instance, was someone who has before started a company in the United States, and there grew a large therapeutic company. And sold it there. So you take co-founders with other knowledge, but obviously most of the time they're researchers starting the companies. Yeah.
Just in a way to follow on question to that. So looking at the map, I was struck that Switzerland seemed the highest. So proportionately more companies there than even in the UK if you look at the population size. And obviously you've described how there's a link between where the companies are and the public infrastructures that they collaborate with. But most of these companies, you also said, are business to business. So their clients are other pharma companies or whatever.
For instance,
So how important is the location of their customers? Is that also part of where they are based, or do they tend to sell to companies in other countries?
I mean, regularly these founders that we've talked to, they somehow originate from these places, so they didn't move too far away actually. So that seems to be the main reason why they found it there. So even the Swiss companies, so we have I think 2 companies from Switzerland in our sample. So I'm from the people that we talked to, and those were also people from Switzerland. And that was the reason why they started their companies there. Obviously, also Switzerland is a very nice, it's a nice place to start a company in the pharmaceutical industry because of the pharmaceutical companies that are there. But the main reason that we actually saw, at least from the people that we talked to, those were the ones that, yeah, they were based there, made their research career in a proximity, or like somehow was born there or some other way associated to it. Yeah.
I quite like your 2x2 grid, and I know Nicholas is a big fan of 2x2 grids.
Really?
So, have you mapped the companies to that grid?
Yes. So actually, it's like pretty interesting because they move through the grid a little bit, and that's what
then my follow-up question is, you perhaps have already answered, is there a difference in the risk profile based on the cell of the grid?
The risk profile?
Yes, in terms of their longevity and whether they've had to pivot.
Yeah, so that's regularly the field where they pivoted at some point. Because I think this is why the scaling dimension is interesting. I mean, those companies, they are very good at solving a lot of different problems, but none of them repeatedly. And so they engage in all of these projects. They build up a lot of different, maybe ontology, so maybe for plants for instance, so they created a lot of different ways of predicting certain breeds, for instance, so crossing of different breeds. So then they did it across the board, so they're very good at it. But they've never been able, maybe they have never been able to standardize it or to find a stable structure. And once they found it, that's the point where they are then able to look for new investors and then to grow. So when you're here, you tend to be much bigger. So the biggest companies that we have like this, those are rapidly scaled, are here. So here we have one company that has about 250 employees and was founded 5 or 6 years ago. So those were the ones who like really rapidly scaled. Those are the ones who are scaling also quite rapidly, but not as much. And those are the ones. We have even one company here that is ongoing since 2005, and they have not grown so much since then. I think they are also like 12 employees or so. Just because they go from project to project, and they're completely fine with it. So, so if he asks me for risk profile, I would like look for those particularly, and look for those who are able to find a repeatable niche. So all of them, they have like these search engines, for instance. So those could be ones that have search engines, or they have a workflow software or sanitation software, something like that. But if they are able to build something on top of that, like find one product that can do something repeatedly on top of this. So if you had created this this Uber ontology, and then build on top of this Uber ontology a repeatable application, repeatedly solves a problem to someone or to multiple people, then those would be the ones with the less risky. So the less risky profile, and those could go into that direction.
Can you give an example of this?
Yeah. So one company, for instance, so they provide, so they created this kind of an Uber ontology for so Uber ontology sounds really awful, but it's like a quote. so they were able to link different ontologies. So and what they were able to do is then they built on top of that first of all like a search engine to like differentiate between different terms that are close by but not as but do not mean the same things, I would say. And then they created an API on top of that they can sell to different and integrate into different services. And then they have like a software that they pay by usage for this particular API, and that is fairly scalable. If that makes sense.
So most of the companies, or the examples that you referenced, probably fall into the kind of genomics and health data related fields, I would
plants,
say. Yeah.
Plants and
so
microbiome as well.
Yeah, so, but did you kind of get a feeling for what's the next big thing, you know?
Ooh, okay. So that's a tough question.
If you would recommend someone now, which directions you go into and which of the business models they should probably use, what would you recommend?
So yeah, so like I said, I'm currently looking very much at these kind of search engines, and there are at least 2 or 3. So there are a couple of them in Europe already, and these search engines, I'm very curious what are the additional services that they offer on top, and there are a couple of very interesting ones, and also some of them here. So, but the future, it's very hard for me to say. So I don't think that so P2C has shown to be not worth it. So because that hasn't worked too much, and obviously the pharmaceutical industry is obviously very, very interesting, and as we've seen that there are a lot of interesting theoretical usage for genomic data, but that's still a little bit very early to say.
I mean, I think it's actually making sense out of the data, because I think like your browser examples are all leveraging the fact that we have all these non-interoperable data sets, and so time will solve those problems.
But I think there is a step ahead. I mean, that's hopefully their savior. I mean, they are now a little bit a step ahead because they integrate these different infrastructures. But now they have these integrated database, and now they can think of interesting solutions, and they try them out with different industry players. And if they are able to find a solution on top of this, they are the step ahead in front of others. So I think this is why I think those are interesting.
And the search engines that you mentioned, are they search engines for public data or the private data?
They are mostly for both. So for public data, there's a free thing. Yeah. Like all of them, they have this freemium package. So free is public data, and for proprietary data, they offer a premium pack. They all have some kind of a premium package. So then they integrate the public data infrastructures with the private infrastructures that maybe a pharmaceutical company or a biotech company has. So, and that's why it's then interesting for the private companies.
Well, I suppose the difference between FAIR and then their proprietary method of linking is that proprietary method of linking isn't under anyone's review, right? So when FAIR comes along and if everyone's making FAIR data, then all of those ways are actually scientifically rigorous, right? Whereas if they're just saying, oh, we think this ontology matches this ontology, who's going to question that?
Yeah, to some extent, so what they're doing is some kind of a FAIR, right? Because it's findable,
well, no,
it's more or less accessible.
If they're making it sort of open to the public, it would be fair, maybe. But
yeah, so I think the main difference is in 2 things. So first of all, right now, even these search engines, I mean, if they provide a search engine for free to the broader public, and you can search the public infrastructures on this is kind of fair. This is kind of it's accessible then. However, so they own the way they created this interoperability, so they own this ontology, and you don't know how they did it, and you don't know the process how they select what they show to you. So, and this is in some extent is good because in some extent this raises the usability to industry providers, because industry doesn't want to see everything. They want to see only the relevant thing. They want to see the Google results, 10 results, and that's it. So they want to see the relevant facts first. So this is in that sense good. On the other hand, like if you would like to see all the data, that's not that good. And for a company, it's very important to have this kind of a black box, because that helps them leverage this kind of data set later on. Does it make sense?
It totally does. I think it's science's mission to make it necessarily. It's right, Karen.
So maybe one more question.
Sure, thank you.
With your categorization, how much of it is down to what you say about working on project to project, or working on something sustainable, and how much of it how much of it is down to scientists being naive? So if a big company comes to you and says, I've got this problem, solve it for me. You write software specifically to solve it for them and give it to them. As opposed to saying, I'm going to write this software for your problem, I'm going to license it to you, and then I can have a sustainable income because I own the product and you are using it for me.
That's a very interesting question, I must say. So I'm not saying anything about the kind of, but that's a really strategic approach. I don't think that's a strategic approach. I think it's some kind of a naivety that they do these kind of projects. Not all of them, of course. So I know that some of them are fairly open about their kind of naivety. So then there it is a strategy because they are just happy. And they even say to me, "We're happy with 10 people, and we don't want to grow. We're happy doing this. We have this one product, this one customer. Very good." But yeah, so I would agree to you to some extent that it's just what scientists have done so far: project, grant, and then they keep on doing this. But as you have a company, you have to find a sustainable model, and particularly when there are external factors that would lead to you rethinking this, and those external factors are nearly always investors, I would say. So investors will always tell you that this is not what they are looking for. They are looking for what they call traction. They are looking for repeatable business. Sorry.
Yeah, I might just mention that in terms of looking at software startups, and so again, there's a lot of research on how do you build up generic software. So kind of with the generification strategy, still most of the startups start with a dedicated customer. Initially build up really a working prototype and learn from that experience. So it's not just naivety, but because there's so much learning that goes on in building that initial solution.
Sure, but the question is whether they learn, whether they really learn. So I've counted a couple that learned that, like I said, so after 120 projects, we learned annotation software is something that we repeatedly do, so maybe that's something that we should do. But not all of them are really you have this really learning curve. It's just hope the next project comes and that's fine. So building a software for 4 years for one customer, then getting it audited for the next 2 years. So for working for one customer for 6 years just to get the software ready, and then thinking that's a good thing, I'm not really sure whether that's a sustainable approach.
Yes, but again, in software, usually it's in 3 months or 6 months. So again,
no, they really worked years on this.
Yes,
at least that's what they said. Yeah.
Well, yes, but I was just making an analogy in terms of just a typical software startup.
That's true. Yeah, so like an app, I can create an app within a month. That's true. Yeah.
Okay. Well, thank you very much.